Hello and welcome back to chemistry. So for the past 2 weeks, the only thing we have discussed is hydrocarbons, which essentially are organic compounds that consist of hydrogen and carbon. We look at these three groups: alkane, alkene, and alkyl. And I really don't want to sell them short because they are amazing. You can have so many different useful products that you can make from these groups. You can make a variety of plastics, and you can obtain a variety of fuels like octane, which is petrol, and then methane gas, and then LPG. So you can get a lot out of the hydrocarbons. However, there are 118, I think, elements naturally occurring and man-made. So it would be rather disappointing if the entire field of organic chemistry only uses two elements, carbon and hydrogen. And if you look at the plastic groups that I showed you last lesson, hydrocarbons are only responsible for HDPE, which is a polyethylene, LDPE, which is another polyethylene, and PP, which is a polypropylene. The rest of the plastics require other elements beside carbon and hydrogen to be present in the polymer. So what we're going to talk about today is the presence of some other elements and the presence of some other groups and some other properties that they will give to the organic compounds. Actually, I don't think we're going to talk about that today. Before we can do all of that, we need to name a few more types of organic compounds. So I'm opening that can of worm, which I've kind of kept the lid shut for like 2 weeks, just so you get used to some of the naming. But what we're going to talk about today is to give you 4 more homologous series or groups, if you will. These 4: carboxylic acid, amine, alcohol, and haloalkane. So these are still organic compounds, but they have something beside carbon and hydrogen, and that's why they have different names. So that's all we're going to do today. We're going to look at some of their chemical properties next week. All right, the naming rules still apply, so you really want to have this in front of you whenever you do any naming question. We're actually going to focus on like things like functional groups a little bit more today, and things like priority, parent functional group, and other groups. Okay, so let's talk about the concept of functional groups, which technically speaking, this is not a functional group, so it's really only these 3. A functional group is a group that gives an organic compound some functions. Oh, shocking. Okay, so functional groups are atoms or groups of atoms bonded to the carbon backbone that contains element other than carbon and hydrogen, so it's not hydrocarbon, and affect the chemical properties of the compounds, which is how the compound react. This is a very, very vague definition. What chemical properties? That really depends on the functional group. I think I might need to fix this, but essentially is anything that's not the hydrocarbon that's linked to the carbon backbone in an organic compound. By adding a functional group, this usually make the compound more reactive. We'll talk about chemical reaction in a lot of details in year 12, organic chemistry, which is unit 4. The entire unit is organic chemistry. But in year 11, we're going to look at, I say, maybe 1 or 2 reactions. So the only chemical reaction that I have shown you so far is the addition of alkene. So if you have an alkene, it can undergo addition. That's, however, I can't spell. It can undergo addition. That's the only chemical reaction that we have looked at so far. But when you introduce functional group into a hydrocarbon, the group can do so many more than just addition. All right, the first functional group that we're going to look at is carboxylic acid. A carboxylic acid is a COOH group covalently linked to a hydrocarbon. And I'm just gonna, where am I gonna draw that? So let's say you have a hydrocarbon. So this is the rest of the molecule. I can put a C here, but it is going to have a C, double bond O on one side. The C then single bond to another oxygen, which itself is single bond to a hydrogen. this is a carboxylic acid. So including the carbon. Carboxylic acid is a very interesting functional group because the group itself has a carbon in it. There are, all right, people do not like this, but there are two different types of names that you have to get used to. The family name, which is carboxylic acid, but the actual name of this group is a carboxyl. So if I ask you what functional group it has, you're actually supposed to say that it has a carboxyl group and not a carboxylic acid. So this particular structure is not called a carboxylic acid, it's called a carboxyl. I don't know why I didn't come up with these notations. Okay, it has a suffix because it's no longer an alkene, alkane, or alkyl. So the suffix for carboxylic acid is oic acid. And well, this is what it is. Probably a good idea to tell you. So I'll show you the examples. I was going to talk about physical properties. Yes, let's talk about physical properties. So an C double bond O, OH can form hydrogen bonds. This is actually very, very interesting because of the way that the two carboxylic acid molecules can orient themselves. So you can have like and then maybe there's a C here, double bond O, and then O, and then H. So if the two carboxyl groups rearrange themselves in this manner, you can actually form two hydrogen bonds between, this is the positive dipole, and then that's the negative dipole, positive dipole, negative dipole. So you can form two hydrogen bonds between two carboxyl groups, and this particular structure is called a dimer. So very, very strong intermolecular forces because you have two hydrogen bonds per pair of carboxyl groups. Okay, let's talk naming. What do I want? I want the name and the condensed formula for the organic molecules. Maybe I do the skeletal as well. So follow the naming rules. Step 1 is to determine the suffix. This has a carboxyl group, so C double bond O, single bond O, and then H. So the suffix is going to be oic acid. Step 2 is to determine the longest carbon chain. You need to count this carbon as part of your longest carbon chain. So this carbon chain has basically one carbon, which is meth. There is no branching or anything. So I don't need to do step 3. And step 4, you definitely don't need to number the functional group if there is only one carbon. So you can skip that as well. So the name of this is just oh, I do have to point out. You want to show that the rest of the molecule contains single carbon hydrogen bond. So the rest is an alkane. And what you're going to do in order to show that is to put an AN after the meth. Okay, so meth, there is one carbon in the longest chain. AN, to show that beside the carboxyl group, the rest of the molecule is made of hydrocarbons, or alkanes specifically. So meth in oic acid. So the oic acids are here. Or methanoic acid. Meth, one carbon, one C, AN. Rest of the molecule is alkane. So the rest is alkane. And suffix, so contain carboxyl. Methanoic acid. Example 2, let's try that again. So once again, suffix, the functional group is oic acid or carboxyl. So oic acid. Longest carbon chain, 2 carbons. So eth. And the rest of the molecule is alkane. So the rest is AN, so eth-N. There is no branching, and you will never have to number the position of the carboxyl group. I know you didn't have to do it in the previous example because there was only one carbon atom, but you don't have to do it ever because the carboxyl group is always on the first carbon because it requires a carbon. So the carboxyl group is on C1 always. It's always on C1 because it itself requires a carbon. So no numbering is required. You have to number if you have a branch, and we'll talk about that later, but you never have to indicate the position of the carboxyl group. It is not required. So I'm just going to name it. So 2 carbon, eth. The rest of the molecule is hydrocarbon alkane, so ethanoic acid. Ethanoic acid, which is the scientific name of vinegar. It's an acid, it's sour, things like that. So ethanoic acid. I forgot to do semi-structural formula, condensed formula. So CH3COOH is going to be this one. And the previous one was HCOOH. You can't do CH, not, so it's not CHCOOH for the previous one because, oh sorry, it's not CHOOH because the this O doesn't actually have a bond with this C, and this looks really, so don't do that. The COOH has to be clearly shown in your condensed formula. So HCOOH and CH3COOH. I had an old student that just went, "Kachoo, everyone, this thing is done." Anyway, so example 3. Okay, let's do that again. So C double bond O OH, number 1. So it's a carboxyl group. Oic acid is a suffix. Longest carbon chain. 1, 2, 3, 4, 5. 5. So pent. The rest of the molecule is alkane, so AN. No branching. You don't have to number the carboxyl group. So pent in oic acid or pentanoic acid. Condensed formula CH3. I'm gonna combine these, so CH2 cube, not cube, sorry, 3, COOH. That would be the condensed formula. Second functional group is the acno. Now acno is actually the official scientific name, but we always call it alcohol because acno just sounds kind of pretentious. Okay, it's like saying unconscious coupling. So an alcohol on alkanol is essentially a OH, so O covalently linked to a H, which itself is linked to a carbon in a hydrocarbon. That will be the alcohol. So this functional group doesn't have a carbon in it. Family name is alkanol, and the OH group, so the actual functional group name is hydroxyl. So this is a hydroxyl group. It has a suffix of OL, no, OL, but it also have a prefix, which is hydroxy. And this is what it looks like. Now, very similar to carboxylic acid or the carboxyl groups, the OH or the hydroxyl group could also form hydrogen bonds between 2 molecules. So I don't even know what I'm doing. That's not. The reason why it's like this is because normally we put an R here just to indicate the rest of the molecule, the residues, so the hydrocarbon residues. But you normally only have one though, mainly because of, actually it looks like you can have 2 here, but you really only have 1 because this is too, well, the shape is not linear. So you will have 1 hydrogen bond between one OH and another OH. I think I'm just going to hack the shape here so it doesn't look like you can form another one. So only the carboxyl groups, only 2 carboxyl groups between 2 molecules can have 2 hydrogen bonds. This one only have 1 hydrogen bond. Okay. So let's talk about naming. So again, if you look at this, you can see that there is an OH at the end. So this is a hydroxyl group, which means that I'm going to have a suffix of OL, not oil, OL. There are 2 carbon atoms in the longest chain, so 2C, which is eth. The rest of the molecule is alkane, so you also have to use the AN. Rest is alkane, or the rest is alkane. So IN, there is no branching, and you don't have to number or indicate the position of the hydroxyl group in this case because there are 2 carbon atoms, so it's always on carbon 1. So you can skip step 4, and the name is SNOL, SNO, ethanol. This is drinking alcohol, by the way. Some of you probably have heard of ethanol, but it's really eth, so 2 carbon, N for the rest being alkane, and then OL for the alcohol group. Let's do this one. So once again, we have OH, so the hydroxyl group, so the suffix is OL. Longest carbon chain, 1, 2, 3, 4, 5, 6. So 6 carbon, which is hex. The rest is alkane. So IN. No branching so far, but you do need to indicate the position of the hydroxyl group in this case because it can be here or here or here. Well, the other 3 would just be the same. So it is on carbon 1. You always start numbering from the end closest to the functional group. So I've numbered. I really just care about that one. And then name, hex, 6 carbon, N. The rest is alkane. And 1. So the alcohol is on carbon 1, O. Hexane 1O. Don't say hexanol. Hexane 1O is more accurate. All right, let's do this one. This one has a branch. Again, I'm going to do that. So oic acid, sorry, OL, not sure what happened there. Hydroxyl group, longest carbon chain. The longest carbon chain that you include, and I don't think it matters in this case, but you have to, your longest carbon chain has to contain your functional group. So in this case, it's 3. So 3C, which is prop. The rest is alkane. So AN. And then there's a branch this time. The branch is a methyl. I do need to indicate, I don't have to indicate the position of the branch, but I have to indicate the position of the hydroxyl, but in this case in the middle, so it doesn't matter from which end I start numbering. And name, so methyl. You don't have to say 2-methyl, it has to be on the second carbon. Methyl prop, 3 carbon, N, the rest is alkane. 2, sorry, not 1. Methyl propane 2O is the name of this. Okay, I need to fix that. All right, this is interesting. Look at this. This has 2 functional groups. So there is one here. This is the carboxyl. And there is one here. This is the hydroxyl. So when you have 2 functional groups and they are competing, well, they potentially can have suffixes. So you have to make a decision on which functional group will take the suffix. And if one of them takes the suffix, what happened to the other one? And this is where I need to talk about this, which is the priority table. This is just part of the naming convention, so it is by no means saying that one functional group is more reactive or important than another functional group. So I'm not trying to discriminate between the functional groups here. This is purely for naming conventions to be consistent. So if more than one functional group is present, the functional group with the highest priority, and the higher the priority, the lower the number. So if something is priority number 1, is the highest priority. Some people got confused by that in previous years. The functional group with the highest priority will be the parent functional group and will give the suffix. All other functional groups will become branches. This is not the complete priority table, and the priority table will go on for more than 12 entries, but you need to know 12 for VCE, and we're going to learn this many in this lesson, not this year. We have 2 more next lesson. So if you look at the priority table, carboxylic acid as a group is priority number 1. So whenever carboxylic acid is present, it's going to take the suffix, and everything else will become prefix. So the example that we just looked at, we had 2 groups, carboxyl and hydroxyl. Carboxyl is going to be the suffix, and you're going to treat the hydroxyl group as a branch, and you're going to use the prefix hydroxy without the L to name it. So this is going suffix, it's going to be oic acid. Whenever you see carboxylic acid or carboxyl, it's going to take the suffix. So oic acid, because carboxyl has a higher priority. Again, this is only a naming convention. I'm not saying that an acid is more important than an alcohol. So this hydroxyl, it's going to be a branch, and you're going to name it hydroxy. I'm just going to write here, this is the branch. Hydroxy is the prefix form of alcohol or hydroxyl. Again, don't blame me, I didn't come up with these names that sound kind of similar but not the same. So number 2, longest carbon chain, 1, 2, 3, 4. So 4C, bute. The rest of the molecule is alkane, so you're going to need AN as well. It'd be interesting you have a double bond here, but we'll do that in year 12. Okay, so the hydroxy is a branch, which I have named, and I do need to number the carbon chain just to indicate the position of the branch, because this OH could be here or here as well. So always start numbering from the end closest to the functional group. So the carboxyl is always on carbon 1, and then 2, and then 3, and then 4. So in this case, the branch is on carbon 4, and then I'm just going to name it. So 4-hydroxy butane, bute, AN, oic acid. 4-hydroxybutanoic acid is the name of this molecule. Let's do one more. Again, oh, this is not a very good structural formula. I need to do the condensed formula. I keep forgetting. I'll do it later. So this is the carboxyl. Or maybe just delete it in the question. And then you have the hydroxyl. No, I need to do the condensed formula. I finish this example and then I do the condensed formula. Again, between carboxyl and hydroxyl, the carboxyl is going to take higher priority. So the carboxyl will be the suffix and the hydroxyl will be a branch called hydroxy. I'm just going to write the branch name here. So oic acid is the suffix. Longest carbon chain, 1, 2, 3, 4, 5. So absolutely you need your longest chain to contain both the carboxyl group and the hydroxyl group. 5C, pent. It has an AN because the rest of the molecule is hydrocarbon. So you have a hydroxy branch, but there is an extra branch here, which is a methyl. So 2 branches, a methyl branch, a hydroxy branch. And I'm going to start numbering from the carboxyl group. So 1, 2, 3, 4, 5. And let's name it. So hydroxy H comes before M. So you're going to order your branches alphabetically. So 3-hydroxy, 4-methyl, pent, an, oic acid. You can do it. No. Okay. 3-hydroxy 4-methyl pentanoic acid is this name. All right, let's go back and do condensed formulas before I start the next group. You can start from this end, but if you do that, you have to go HOOC just to show where the carbon chain, and then CH2, CHOH, CH. Because I'm lazy, I'm just going to put both of these in brackets. Or you can start from this end, or if you start from this end, carbon 5, we go CH3, CH, CH3, CH, bracket OH. So put a bracket whenever you have a branch, CH2, COOH. So it's a little bit easier to see the COOH. Notice how you can see all of the functional groups if you look at the condensed formula. All right, let me name this one. So I will start from this end. So I'll put CH2. You can go HO. I'll do CH2OH like this. CH2, CH2, COOH. So that's example 7. And this one, CH3. Oh, this one's good. Okay, CH3 2 OH. You can do it like this because essentially this OH is linked to this C, which is not incorrect. One more, CH3, CH2, 1, 2, 3, 4, 4, CH2 OH. Is there an example 3? CH3, CH2. Did I do 3? I think I did the other one. I think that's it for this video.